Hello dear students, good evening to each and everyone. So first of all tell me, am I audible properly? Audio and video both are clear to you people? We are studying signals and system in very much comprehensive manner, and in next 3 to 4 lectures we will finish the Fourier series, continuous time Fourier series. Okay, so this is lecture number 47 and part 10 of the continuous time Fourier series. So today we will study some different properties of Fourier series that can help us in the solving complex question. We can solve all the question or most of the question by using the different properties of Fourier series. So we need to understand each and every property from very basic, and wherever proof is required, definitely I provide you the proof also. See, in GATE exam, they are asking just question, MCQ question or NED question or multiple select question. They are not asking a theoretical type question, or they are not asking the proof of the any property. Okay, see, they can ask the property, proof of the property in ECE conventional type paper or subjective type paper, but here simply you have to understand, or you have to focus more on how to utilize the property in the question rather than mugging up the proof of the given property. So don't focus more on proof of the given property, just focus just focus on what is the property says and how to utilize this property in the given in the different question. Okay, so the first property is linearity property. Again I am telling guys, wherever proof is required, definitely I will provide you proof also. Okay, so let us start guys. First property is linearity property. So this property says that if Fourier series coefficient of the periodic signal x1 of t is Fourier series coefficient of one signal x of t is Cn, and one more signal, let us consider x2 of t, and its Fourier series coefficient is Bn. Coefficient is, then what we can say, if you multiply this x1 of t with alpha, constant alpha, then corresponding coefficient Cn also will get multiplied with alpha, same factor alpha. Okay, so here I am writing alpha into, in the same way, if you multiply x2 with beta, x2 of t with beta, then corresponding coefficient also will get multiplied with beta. So beta into alpha and beta both are any type of constant. It can be positive, it can be negative, it can be greater than 1 or it can be less than 1, correct? And why this is happening guys? Because we are talking about the linear system. The property name is linearity, linear. So and if you add these two, then corresponding coefficient also will get add, correct? This is what linearity property. Again I am telling, the Fourier series coefficient of x1 of t is Cn, one more periodic signal x2 of t, and its Fourier series coefficient Bn, then alpha x1 of t plus beta x2 of t, and its Fourier series coefficient will be alpha Cn plus beta into Bn. Okay, so this is known as a linearity property. Okay, any doubt in this? Tell me, is this clear? I hope all the students are getting. Okay, fine. Now next property, next is very much important property, guys. If the Fourier series coefficient of one periodic signal x of t is Cn, then you shift x of t either by right side or either right side or left side by certain amount of time, like left shift or right shift by certain amount of time, then the corresponding coefficient is equal to the power minus j omega n omega 0 into t0 into the extra term will get multiplied with Cn t minus t naught, then here you will get e power minus j n omega 0, n omega 0 is the frequency into t naught Cn. See here minus t naught, then here also minus t naught will come into picture. Suppose here it is plus t naught, then here plus t naught will come into picture, correct? Minus t naught, then minus t naught, plus t naught, then plus t naught. Let me write the proof of property. Now here the Fourier series coefficient of x of t Cn. So x of t is given by the exponential Fourier series is given by, here coefficient is Cn, n is from minus infinite to plus infinite into e to the power j n omega 0 t0, correct? Then now here left hand side, left of the equal to t become t minus t naught. Then right hand side also t become t minus t naught. You are replacing this t with t minus t naught. Same change occurs on right side of this equation. This t naught. You have to replace this t with t minus t naught everywhere. So here it will be Tn into e to the power j n omega 0 t minus t naught, correct? So here x of t minus t naught, which is equal to summation n is from minus infinite to plus infinite Tn into e to the power minus j n omega 0 t0 into e to the power j n omega 0 t0, correct? Now you can observe here, guys, compare this and this one, guys, compare this thing and this one. Here you can see Tn is a coefficient of x of t. You can see here Tn is a Fourier series coefficient of x of t. Tn is a Fourier series coefficient of x of t. Then can we say this term is nothing but the Fourier series coefficient of x of t minus t naught? Can you write like this? Tell me. If the Cn is Fourier series coefficient of x of t, you compare this with this, then after the comparison, sorry, here t only, here t. After the comparison, we can say this is the Fourier series coefficient of x of t minus t naught, as here I wrote, correct? Fine. Yes, Sinchan Reddy, I will try my best for providing the valuable content, okay, to you people. So this is the second property. This is the second property, guys. Linearity property. Remember this thing here. T become t minus t naught. Then it become, here it will be e power minus j n omega 0 t naught Cn minus t naught. Then here minus t naught. If it is plus t naught, then here it will be plus t naught. Of course. Here. So this is the second property. Now let us come to the next property, time reversal property. So time reversal property says that if the Fourier series coefficient of if the Fourier series coefficient of x of t is Tn, then if you replace t with minus t, that is time reversal operation, then here n become minus n. Tn also holding with respect to y axis. If you replace t with minus t, so here also you have to replace n with minus n with minus n, correct? So right side samples will come to the left side samples will come to the right side, simple, holding with respect to y axis. Okay. Here also we can prove this property, guys, but as I told you, wherever proof is required, then definitely we will prove. Okay. So do you want proof of this property? Tell me, Sinchan, Reddy, if you want, then I can prove this property also. Okay, yes, you can do it, very good. Okay, similarly t become minus t, n become minus n. Next is time scaling property. This is also very much important property. Time scaling property says that if the Fourier series coefficient of x of t is Fourier series coefficient of x of t is Tn, then here time expansion, it can be compression. So t become suppose a into t. So depending on a, it become compression or expansion. If a is greater than 1, then compression, signal width decreases, fundamental time period also decreases. See, x of t is periodic. X of t is periodic signal. X of t periodic signal, of course, periodic with the fundamental time period capital T. Then what will be the fundamental time period of x of 2t? Tell me. And the frequency omega 0, fundamental frequency omega 0. So tell me, then x of 2t also it will be periodic, guys. It is the periodic, but what will be the fundamental time period? Can you tell me in the comment box? Sinchan Reddy, if you are present, can you tell me? The x of 2t means compression by factor of 2, guys. Also there is a change in the fundamental time period, fundamental frequency, fundamental time period become t by 2, guys, of course, and the fundamental frequency double, because frequency and time period both are inverse of each other. So increment in the fundamental frequency, correct? Okay, and suppose I am writing x of t upon 3, x of t by 3, so again will be the periodic signal, but now this time expansion by factor of 3, the fundamental time period will be, and the frequency will be, correct? Okay, very good. Swagat also present, very good. Swagat, you are also correct. Okay, so guys, here in general t become 80, then see there is no change in the Fourier series coefficient, amplitude of the Fourier series coefficient. There is no change in the amplitude of the Fourier series coefficient. The coefficient remains same, but there is a change in the fundamental frequency. Suppose here fundamental frequency omega 0, the fundamental time period t, guys. Then here value of sample, or we can say amplitude of the sample remains same, but distance between sample will be changed. How? That I will explain you with one example, don't worry. Okay, so here the fundamental frequency, now t become 80, guys. You can see here t become 2t, so fundamental frequency become 2 omega 0. So here it will be mod a omega 0. Why I am taking mod? I am taking mod, guys, because it can be negative. A can be negative, but frequency cannot be negative, and the fundamental time period will be t divided by mod a, correct? Frequency cannot be negative, so that's why I am writing mod A omega 0 and T upon mod A. Fine, clear? Now see how. If you want proof, then also I can give you proof also guys, and you want example, you want proof through example, or you want example based on this, then also I can give you. So tell me, you want proof or example based on this? What do you want from this property? Do you want one example based on this, or you want proof? What do you want? See, or both you want? Example, okay, very good. Example you want? Say for example, suppose x of t is one periodic signal with the fundamental ampere capital D and the fundamental frequency omega 0, and its a Fourier series coefficient is Cn, and Cn is given by writing here Cn. Here I am writing n omega 0, correct? Here I am writing Cn. Suppose this Cn guys. This is just an example, okay? This is just an example. Okay, this is just an example. Let us consider this is C0, this is C1, C2, correct? This is C minus 1, C minus 2. This is 0, then this is what? Omega 0, will be 2 omega 0, then 3 omega 0, so on, minus omega 0, minus 2 omega 0, and so on. Clear? Now find exponential Fourier series coefficient of number 1 x of t and number 2 x of t by 3. Okay. Now see, first I am writing first one. First I am taking x of 2t guys. So in x of 2t, the fundamental time period, according to the fundamental time period, will be 2 by t by 2, and the frequency will be 2 omega, correct? Frequency will be 2 omega 0. So here this frequency omega 0 become 2 omega 0. Simply what you have to replace guys? Omega 0 become 2 omega 0. See, t become t by 2 and this omega 0 become 2 omega 0. So simply what you have to replace guys? See, there is no change in the coefficient value guys. There is no change in the amplitude of each and every coefficient. But spacing between the samples will increase or decrease. Spacing between samples, because this omega 0 become 2 omega 0. Here also omega 0 become 2 omega 0. So it will be 4 omega 0. So what exactly I am going to say guys? Here we will find the extraction, we can say, or spacing between samples. Again I am writing, suppose n omega 0, the Cn remains same, origin remains same, C0 become C0, but see this omega 0, now it will be at 2 omega 0, it will be at 2 omega 0, this 2 omega 0, it will be at 4 omega 0, because you are replacing omega 0 with 2 omega 0. You have to replace omega 0 with 2 omega 0 everywhere. Correct? This is C0, C1, minus 1 and minus 2. Now you have to replace omega 0 with 2 omega 0. Replace omega 0 with 2 omega 0. If we replace omega 0 with 2 omega 0, then it will be at 2 omega 0. Then next it will be at 4 omega 0, guys. 4 omega 0. Then it will be at minus 2 omega 0. Minus 4 omega 0, that's it. Correct? At omega 0, you will get 0. At omega 0, you get 0, guys. Also 0. Here also 0. Here also 0. Are you getting? One kind of, you can see, interpolation. Is this clear, guys? So here, compression in time domain correspond to expansion in frequency domain. Can we say like this? Compression, x of 2t means compression in time domain correspond to expansion in the frequency domain. Is this clear? Fine. Okay. Now see next question. The similar way, second is x of by x of t by 3 means get the fundamental expansion. The fundamental time period will be, and the fundamental frequency omega 0 by 3. See, you have to replace each and every frequency by omega 0 by 3. So this will be at omega 0 by 3. This will be at 2 omega 0 by 3. Simply replace omega 0 with omega 0 by 3, guys. Correct? Just wait for a minute. Okay. So here again there is no change in the samples amplitude, guys, but spacing between samples decreases, guys. Yes or no? This is the only change. The only change. Now see, this 0. Now to replace omega 0 with omega 0 by 3. So if you replace here omega 0 with omega 0 by 3, guys. So here omega 0 by 3 compression, you will find one kind of compression. Then here 2 omega 0 by 3, guys. Here minus omega 0 by 3. It will be minus 2 omega 0 by 3 1. Yes or no? Tell me, is here what again? What I'm going to say, guys? See, this is what expansion or compression in the frequency domain. 1 minus 1 minus 2. So you can see here x of t by 3 means what? Expansion. The expansion in time domain correspond to compression in the frequency domain, and compression in the time domain correspond to expansion in the frequency domain. Yes or no? So this is very much important conclusion, guys. This is very much important conclusion from this. It can be applicable in the Fourier transform, DTFT, DTFS, DFT, in every concept. So what is the important conclusion? Expansion in one domain correspond to compression in frequency domain and vice versa. Correct? Remember this thing. Or we can say compression in one domain correspond to expansion in the other domain. Fine. I hope this is clear to each and everyone. Swagat and Sinchan Reddy, I hope all of you are getting this one. So let us take the next property, that is the differentiation in time domain property. Differentiation. and here did not require to mod omega 0. I am writing mod because frequency and time cannot be negative, but if you take a equal to minus, then here n become it's fine, n become minus n. But if you write omega 0 become minus omega 0, that is also no issue. Okay, so next property, guys, let us take one more property. Next property is the differentiation in time domain property. Differentiation in time domain property. Okay, so differentiation in time domain property. This property says that if the Fourier series coefficient of x of t is the Fourier series coefficient x of Fourier series x of t of course it is periodic, then to differentiate x of t with respect to t, then what about the Fourier coefficient? Here I am, let me prove this. So again x of t is given by summation n is minus infinite to plus infinite Cn to the power k n omega 0 t, correct? If you differentiate x of t with respect to t, guys, differentiate right side and left side of this equal to with respect to t, dt is equal to, so differentiation for this side with respect to t, so Cn is independent of t, Cn is constant with respect to t. What is the differentiation of this one? So it will be k n omega 0 into e to the power k n omega 0. Now compare this both, guys, compare. So can we say if the Cn is the Fourier series coefficient of x of t, then this term Cn into k n omega 0 the Fourier series coefficient of dx of t by dt. Can we say like this? Of course. See, both are same, just a change in here Cn x of t, here Cn gn omega 0 dx of t by dt. Then here we can write the Fourier series coefficient of this one is k n omega 0 into n. Clear? Fine. Tell me, Swagat and Sinchan Reddy, I hope both of you are getting. Clear? Okay, very good. The similar way to integrate, that is integration in time domain. Can you tell me what will be the answer for this question? Fourier series x of periodic signal x of t n, then what will be the Fourier series coefficient? Integration minus infinite x of tau e tau. What will be the Fourier series? So here we got multiplication by extra term j omega 0 because of differentiation. But because of integration, what we will get? N divided by j n omega 0, correct? Divided by. divided by gen omega 0. Fine. So this is the property number 6. Very good. Next is shift in the frequency domain. Like time shifting property, you can say this is a frequency shifting property. This property says that Fourier series of the periodic signal x of t Tn. Okay. Then multiply this term with e power j m. M is an integer value. M omega 0. We are multiplying x of t with one more function which is function of time. So e power j and m omega 0 t, where m is what? An integer value, guys. An integer value. Then the Fourier series coefficient again shift in the frequency. All the samples will shift towards right side by m or left side by m depending on the value of m. Correct? So here all the samples will shift right side by m or left side by m depending on the value of m. So n become n minus m. Of course, n become n minus m. N become n minus m, guys. So of course it will be either right shift or left shift depending on the value of m. M can be positive, it can be negative. So one more important part, here plus m, then here minus m, right shift. See, t become minus t naught, then right shift. The similar way n become n minus m. All the samples will shift right side by m amount of time or m amount of integer value. Correct? Fine. So here plus m and right shift, and here n become n minus m. Opposite side plus minus plus, guys. Are you getting? The frequency shifting property. The frequency shifting property, what we have seen? Minus t naught, then here minus t naught. If it is plus t naught, then plus t naught. It is a time shifting property. But in the frequency shifting property, opposite side. Plus m, then become minus m, minus n become plus m. Is this clear? So all the samples will shift right side or left side by m amount of integer value or m amount of seconds, you can say, or m amount of time. Okay, very good. So this is the frequency shift or shift in the. Next is conjugation property. Property number 8, property number 7, property number 8. Also very much important property, guys. Conjugation property. The Fourier series coefficient x of t is then conjugation. Let us consider this is the complex value signal. If it is a complex value signal, then let us take conjugation of this signal. Conjugation means plus j become minus j become plus j. Then here x conjugate of t, then Fourier series coefficient. First see, n become minus n and then conjugation. Remember this thing. First n become minus n and then conjugation. First replace n with minus n and then you have to do the conjugation operation also. So first replace n with minus n everywhere and then make conjugation. Are you getting what I am saying? So this is also very much important property, guys. And this is for the complex value signal. If x of t is a real value signal, then conjugation of real value signal is that signal itself. the conjugation of real value signal is can you please give example of a complex signal? I have trouble understanding. Okay, okay, definitely. So I will provide you example also, but let us understand this property. So x conjugate of t, x conjugate of t, then it will be x of t only, x of t only, then the corresponding Fourier series coefficient. This case, what we can write? This case, coefficient of this one is what? T conjugation of minus n is equal to, correct? In this case, we can say T conjugation of minus n is equal to, correct, is equal to Cn, guys. So this is very much important property, guys. If x of t is any complex value signal, I can give the proof also, guys. If you want proof, then from the proof you can understand the question also. Swagat, okay? Your doubt will get solved if I provide you the proof. So we can prove this. We can prove this property the same way you can understand question also. So do you want proof? Should I proceed for the proof? Tell me. Tell me in the comment box first. Yes, okay, fine. So let me prove this property. Let me prove this property. Here, x of t minus plus infinity, minus infinity to plus infinity, omega 0. So make the conjugation both this side. Conjugation, right? Coefficient can be complex, as x of t can be complex, Cn can be complex. Cn conjugate power minus, yes or no? Make conjugation both this side. So see, as x of t can be complex value signal, x conjugate of t. Similarly, the coefficient can be a complex value signal. So that's why conjugation of this one is n conjugate and conjugation of this one is plus j become minus j. Correct? Fine. Okay. Now see here. Replace n with minus n. Replace n with minus n both this side. Replace n with minus n. Then is there any change in the limit? Yes, it will be plus infinity to minus infinity. Replace n with minus n. Then the limit will be n is from, of course, plus infinite to minus infinite, n with minus n, n with minus n, and here also n with minus n. Simply replace n with minus n everywhere. Wherever n, then replace n with minus n. So n with minus n with minus n, minus minus plus. Now see, if you do the summation from 1 to 5 or 5 to 1, both are same. There is no change in answer. There is no change in answer. Okay. Here you can interchange the limit of this summation. So x conjugate of t is equal to summation n is from minus infinite to plus infinite. T conjugation of minus n to the power k n omega 0 t. Now you can compare, guys. You can compare the coefficient of x of t is cn. If the cn is the Fourier series coefficient of x of t, then what we can say is the minus n conjugation the Fourier series coefficient of x of t. Now see, you can see here, see, we are replacing n with minus n, then conjugation. Or first do the you can do the conjugation, then you can replace n with minus n. Correct? Replace n with minus n, then you can do it conjugation, or first you can do the conjugation, then replace n with minus n. Both the case you will get the correct answer. This is fine. So you can observe the concept in question using this. Okay, same concept is applicable in each and every question also. So exactly I don't have exactly as of now I don't have right now don't have the correct exact example that you are asking. Okay, but in next in next class I will try to provide the example complex value signal. There are examples, don't worry, but I need to find in the books. Okay, so we are continuing with the our topic, that is properties. Next property is convolution property. So convolution in time domain correspond to the multiplication in the other domain and vice versa also true, guys. Here if the Fourier series coefficient of t is Fourier series coefficient of x of t n, and one more signal, the Fourier series coefficient x of t is n, let be. And one more important thing, guys, you people are from the South India, I think, but what I am saying, guys, see, my English is not that much fluent. I cannot speak English in very much fluent. Okay, so you have to adjust, you have to compromise. Okay, and if wherever you find the doubt, you can ask. Definitely, I will try to solve your all doubts, because your doubts, each and every doubt is genuine for me. Correct? Then here, perform the convolution between these two. What will be the effect of its x1 of t convolution x2 of t, and convolution in time domain correspond to multiplication here capital T into, you have to multiply the fundamental time period capital T, which is the LCM of fundamental time period x1 of t and the fundamental time period of x2 of t. Tn into Bn into t, extra term t will get proof, and this t is nothing but LCM of the fundamental time period of x1 of t and the fundamental time period of x of t. The periodic, the fundamental time period t1, the periodic with the fundamental time period t2, and this t is nothing but LCM of, correct? Okay, fine. So simply what you have to remember, the convolution in time domain correspond to the multiplication in the frequency element, but here in this Fourier series you have to remember this also, fundamental time period t, the LCM of the usual signal fundamental time, correct? So here also proof is available, but again I am telling, not needed, correct? Next is question number 10, multiplication, opposite property, multiplication time domain. So vice versa, guys, multiplication in time domain correspond to convolution in the frequency domain. Okay, the Fourier series coefficient x of t is one more signal, more periodic signal, Fourier series x of t is, then 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 the Fourier series coefficient of x1 of t into x2 of t multiplication. Multiply these two signals in the time domain, then there is a convolution between coefficient in the frequency. Corresponding Fourier series coefficient and the discrete and also discrete. How to write the how to perform the convolution? Summation k n minus k, or we can write bk to cn minus k, like second chapter, like x of k into h of n minus k, or h of k into x of n minus k. So here it is ck into bn minus k, where k is minus infinite to plus infinite. Correct? Just wait for a minute. Continue guys. So here multiplication in time domain correspond to the convolution between the coefficient. Now property number 9 was 8 and this is 10, and now next is 11 guys. Parshall's power theorem, that also already I told you guys. You can calculate power from x of t and you can calculate power from all the coefficients. The Fourier series coefficient says, or Fourier series representation says, how the total power is distributed over the different frequencies. Okay, so here the already we have seen this. You can remember the Fourier series coefficient of x of t, Fourier series x of t is Tn. So with the help of Tn or exponential Fourier series coefficient of c, you have a n n, correct, a0 n bn n minus n of course and n, correct. With the help of all these coefficients you can find the power also. Then according to the Parshall's power theorem, then we can say, then power, average power of x of t given by x of t The periodic signal 1 by capital T integration over a fundamental time period mod x of t. What I am writing because it can be a complex value signal. Formula we already studied in the first chapter, and the same power we can get from the coefficient. The discrete, that's why summation can be a complex value. So mod square n is from minus infinity plus n. Now we know that mod Cn equal to mod C minus n. Simply you can calculate, you can do the summation from n equal to 1 to infinite, and you can make it double. Okay, calculate total. Already we have seen this mod C0 square plus summation n is from 1 and 2 times plus 2 times summation n is 1 to infinite mod Cn, correct? Now using a0, an, bn also we can get the same power, a0 square plus summation n is 1 to infinite an square plus n square divided by an square plus bn square divided by 2. Okay, an square bn square divided by 2. So see again, if an is a complex value signal, then your complex value, then you can take modulus also, and using dn also, using dn also guys, you can calculate the total power. So square plus summation n is from 1 infinite equal to 1 to infinite mod n square divided by 2 mod dn, because dn can be a complex value signal, mod n square divided by 2. Okay, mod dn square divided by 2. Already we know that mod dn square equal to an square plus b. So this is what Parseval's power theorem. Fine. This property number 11. Next, yes. So we completed all the properties, guys. Okay. So in next class, guys, let me finish this class here. Next class we'll study. I will teach a small topic like the Dirichlet conditions for the existence. If you want to calculate the Fourier series of any signal, and it should satisfy the Dirichlet conditions. So that I will explain with the example, and then we will see the limitations of the Fourier series, and then we will solve some questions based on the properties of Fourier series at the end of this chapter. Fine. Okay. So you have to provide the valuable feedback in the comment box after completion of this session. So Sinchan Reddy and Swagat, I am requesting both of you to provide your valuable feedback in the comment box after completion of this session, and next part we will continue into subsequent module. Thank you guys. Thank you so much.